2 of simplifying some trig identities. And so once again, you're going to want to have out for today our trig properties sheet, which we got last week. So it looks like this. So grab that. We're going to be using those today. And also just in the top corner, I'm going to refresh our memories of our 3 Pythagorean identities, which were sine squared of theta plus cosine squared of theta equals 1. One plus tangent squared of theta equals secant squared of theta. And cotangent squared of theta plus 1 equals cosecant squared of theta. As we're working through today, once again, I'm trying to model some things like the examples to match up with the problems you're going to do for your assignment. And so really definitely want to use your notes as you're working through the assignment. So the first example that I want us to do just has to do with maybe doing some multiplication and rewriting. And so we're going to try to use basic identities. So simplify, and the instructions for my simplifying are to an expression with only sines and cosines. And so what that means is that kind of introduction to when we were doing some of these reciprocal and quotient identities is, if possible, you're going to rewrite some of these things so we only see the word sine and cosine in there, and then you're going to hopefully cancel some things out. So we're going to start with our first example, which is the cosine of x times the tangent of x plus cotangent of x. Okay, so first of all, I'm going to go ahead and rewrite these. So I have cosine of x, I obviously can't rewrite, but using my quotient identities, I'm going to rewrite the tangent and cotangent using the ratios of sine over cosine and cosine over sine. So tangent is the sine over the cosine of x. And then this one is cosine x over sine of x. Okay, so once I've done that, I'm going to go ahead and distribute this cosine of x. When I do that to the first expression, I hope you can see that the cosines on top and bottom cancel. And so I'm just left with the sine of x. You're going to notice in a second, I'm going to put a 1 on the bottom because I'm going to have to put it together with this. But when I distribute that, nothing cancels, and the cosine times the cosine is the cosine squared of x over sine of x. Now, unfortunately, you might be thinking, well, that doesn't look really any more simplified. But remember, we just want to involve sines and cosines, and what I will try to tell you as you're simplifying is if you have something that's a fraction, you are going to want to try to get a common denominator and see if you can put those fractions together. And I know that this wasn't a fraction after the cosines cancel, but I'm going to go ahead and put a 1 on the bottom here. And in order to add those together, this has a sign and this has a 1. So I'm going to go ahead and multiply the top and bottom of this by sine of x over sine of x. Then I get sine squared of x over sine of x. There's nothing to simplify over here. A couple things I want to point out to you. First of all, I do have a common denominator. So I can go ahead and add the numerators together, and what I want you to notice on this is sine squared plus cosine squared. Let's look up here. Is our very first Pythagorean identity. So we can go ahead and take the numerator out and just simplify that to be 1 over sine of x, or that's the same as cosecant of x. Okay, so this very much looks like question number 27 that you're going to do on your homework today. As you're moving through some other things, you're going to be asked to do question 29, and in question 29, I'll tell you you're going to want to just kind of rewrite, and you're going to get a bunch of things to cancel. So I'll give you an example like that too. So I'll call this A, and I'll call this B. So for instance, what if I had sine of x times cosine of x times cotangent of x times secant of x times cosecant of x. Okay, and so once again, our very first step is to follow this. Okay, so we're going to rewrite as sines and cosines and see what things cancel. On this one, that's already written as sine of x and times cosine of x. For cotangent of x, using my quotient identities, I would rewrite that as cosine over sine. And then this is 1 over cosine, and this is 1 over sine. Okay. You can cancel in a lot of different ways, but what I want to point out to you is the sign on top over here and the sign on bottom in the last expression, and this is all multiplication, so I can go ahead and cancel those out. And then the cosine on the top and the cosine on the bottom. Okay. And so I am left with this expression. That's the only thing that doesn't cancel. It is cosine over sine, or another way of writing that is cotangent of x. Okay, and so question 29 in particular is very much like that. Okay, so next, let's do one more that involves a Pythagorean triple or Pythagorean identity, and this one is, let's take the secant of theta minus the tangent of theta, and let's go ahead and put it in a parentheses, and then we're going to take the secant of theta plus the tangent of theta and put it in parentheses. And we're going to divide that by the cosecant of theta. Okay, so you're going to end up seeing this a lot in your true proof stuff, but we do a lot of multiplying where we have like a difference of squares. So I'm just going to walk us through here. If you would multiply the top together, you get secant squared, which I'm going to write like this. If I did the outside, I'd get secant times tangent, and the inside, that would be minus secant times tangent. Okay, so positive secant tangent minus secant tangent. I'm not going to bother writing those down because those are opposite terms and those are going to cancel. Finally, I get to the last things, and that's minus tangent squared of theta. And then we still have this cosecant, which I will rewrite that in a minute. I'm going to try to get some things to cancel first, before I rewrite as sines and cosines. But what I want to point out to you is that sometimes the Pythagorean identities are rearranged. So if we go and look at our second Pythagorean identity, it says 1 plus tangent squared equals secant squared. Okay, I'm just going to kind of do some work up here. 1 plus tangent squared equals secant squared. I hope you can see is if I took the tangent squared and subtracted it off, I would get 1, and then I'd have secant squared minus tangent squared. So the secant squared of an angle minus the tangent squared of an angle equals 1. And I'm pointing that out because when we multiplied these two expressions together, we got secant squared of theta minus tangent squared of theta. So I'm going to go ahead, I'm going to replace that with a 1. Still have the cosecant on the bottom, and then I'm going to rewrite that. So 1 over cosecant is the same thing as the sine of theta. Okay, and so if we're looking at C, as we're going through homework stuff, C is very, very similar to question number 30. And like I said, letter B is very similar to question number 29. Okay, so then I want to move on to a couple more things. Oops. Let's turn the page, if you will. And so 2 things, I guess. I would like us to kind of talk about a second simplifying tip, which is combining fractions. So just how do we do that? Combine the fractions and simplify. To a single trig function. And when I say a single trig function, I mean like it's going to be just a sine, or a sine squared, or cosecant, or cosecant squared. So like there's not going to be any addition left in it. So let's say that I had something like 1 over cosine squared of x plus cosecant squared of x over cotangent squared of x. Okay, and so I know it's sometimes hard to know what to do. I see that this is already 1 over cosine squared, so I'm going to just kind of leave this part alone, but what I am going to do is I am going to rewrite cosecant squared, and it becomes another fraction. Okay, so cosecant squared is 1 over sine squared. Okay, so that's going to go right there. And then I have a division bar, so I have another thing going on there. And I'm going to rewrite the cotangent squared. Right down here. And I'm going to write that as cosine squared over sine squared. Okay, we're not forgetting here that I have to combine these fractions eventually, but there was really nothing I could rewrite this as in terms of trying to make it a sine or a cosine, because it's already written that way. All right, let's go back to some earlier elementary operations. When you divide fractions, you might have heard the phrase keep, change, flip, or you take the numerator and keep it the same, and then you multiply by the reciprocal of the denominator. And so I'm going to rewrite this to see what cancels. So the top is 1 over sine squared, and then I'm going to change this to multiplication. I'm going to flip the denominator, that becomes sine squared over cosine squared. Okay, some interesting things happen. You see hopefully that the sine squareds cancel, and now I notice that I have, dropping this down, I have 1 over cosine squared plus 1 over cosine squared. And when I put those two things together, I get 2 over cosine squared. And another way of writing that, because remember our instructions were to write it as a basic trig function, is that's the same as 2 secant squared x. And so that's as simplified as we can go. Okay. That pretty much wraps up the identities that you're going to work with today on your assignment. You're going to notice that question 33 in particular is really similar to this one. What I want to show you lastly is that there is some factoring. And I know factoring, it seems silly, but it's going to lay the groundwork for when we solve at the end of the week. So just so you understand, I'm going to just show you a couple ways that you can factor expressions. Okay. If you go back to factoring, we had kind of two types of factoring. We had common factoring, and then we had the kind of factoring that was binomials. So like, let's say I had something like this. So hopefully we would say, oh, I remember this. We could factor that into x plus 1 and x plus 2. Okay. How does that relate to what we're doing today? Well, today you're going to see something instead of x squared, you're going to see something like sine squared x, I'm going to relate it to this, plus 3 sine of x plus 2. So instead of an x squared and an x, we have a sine squared and a sine and a 2. And really then, factoring that, relating this back, instead of saying x plus 1 and x plus 2, we would just say, oh, I need a sine of x in the first spots. And then I would need a plus 1 and a plus 2. Okay. And sometimes you might see that you have to do a little work on it first. So like maybe you would see cosine squared of x, and then you would see the plus 2 over the secant of x plus 1. And so there might be something like this where you're going to say, oh, wait a second, this is cosine squared and this doesn't look the same, but 2 divided by secant is really the same as 2 times cosine of x. Okay, and then we can do this. The first terms are cosine, so we'd have cosine of x and cosine of x. And we have to have a 1 and a 1, and 1 times 1 is 1, but when you put that together, let's do our outers and inners, we get a cosine x plus a 1 cosine x, that adds up to 2 cosine x. Okay, so the last part of what you're going to do today is some factoring with trig functions.